Hello, I would like to talk to you today about the recursive mutex and why it's a powerful tool that you should add to your C++ arsenal of tools for whenever you're dealing with multi-threaded problems. So I'm just going to jump right in and go over an example of when you might use this. I have this class here called data. And the whole point of this class is to deal with this vector of ints called my portfolio. So the functions, we might get the size of the portfolio. We might add an int to it. We can add a whole vector of ints to it. And then we could even add more and more functions that interact with this vector of ints. That's the whole point of this class. If I run this code, if I run this main function here, we can see that we have an instance of it. We add a vector of ints to it. And long story short, we then just output end of main. Okay, so you can see I printed here end of main. I'm just doing that just to show that we've reached the end of the main function. Now, what if we knew that this data was going to be accessed on multiple threads? We need a way to make sure that accessing this vector of ints is thread safe. So a very classic way to do this, very, very typical standard way of dealing with these kind of multi-threaded problems is to create a lock. We have this standard mutex here that I've added called portfolio mutex. And then what we would do is, and then in every function that accesses that vector, we're going to lock that mutex so that if another thread comes along and tries to do something with it, it has to wait until the first thread is done and has released the lock on that mutex. Okay, now here's the problem. I'm going to run this program and it's running right now, but it never reaches the end. It never reaches end of main. And the reason for that is because let's walk through this together. We're going to take this vector of ints. We're going to add it here. So we lock the mutex. And then what happens is for every int in that vector, we try to call this function to add that int, and then we hit the lock again. It's already locked here, and before it's released, before we're done with the function, it's trying to lock it again. And so it will never release because the first lock is waiting till everything is done, but the second lock can't proceed until the first lock is released. So we're at a deadlock, actually. So what do we do in this situation? Well, we can turn to the recursive mutex. So this is a pretty straightforward difference from the standard mutex. I'm going to hit run and demonstrate that it now works. We now reach the end of the program. What has happened? What's happened is we stepped into this function here, just like before. We've locked the mutex, so we are safe from other threads from accessing that data. But then when we hit the lock again, recursive mutex allows for this. It is a re-entrant mutex in that it allows you to lock it multiple times on the same thread, infinite times. And you can continue on doing your work, doing what you're doing in that thread. And then whenever you're done with it, and once all of the instances of the unique locks are all released, then and only then can the other threads now have access, to that vector. So that's basically it in a nutshell. I mean, this example is trivial, and there's very, very, very obvious ways around this. But the point is, this can come up in your code where you have multiple functions that definitely need to lock, but they might want to call one another, and this would be a very good use case for a recursive mutex. So just being aware that this exists and understanding what a re-entrant mutex is can greatly sharpen your C++ Ninja skills and help you out in the future. So I hope that helped you guys out. If you have any questions, please ask them in the comments below. Like and subscribe, do all those cool things, and continue being awesome in everything you do in life. All right, thank you.